we are going to present the paper that is a work in progress that is an integrating low power IoT devices to a blockchain based infrastructure. I am Mahina Lashari and I'll be starting off with the introduction, and then we have Muhammad Qayyum Ahsan that will be giving you the proof of concept that has been presented into this paper. So, starting off, we have the IoT devices. As most of us know that IoT is a growing concept and it's more like in thing right now. And we have everything connected to the internet. From our phones to the TVs, air conditioners, microwaves, cars, even your water bottles, name the thing, we have it connected with the IoT. But the main concern that is arising right now is the security. And this is where the blockchain comes in. That is the concept that we are going to present into this paper. So, according to a research by Gartner, it has been predicted that the size of IoT devices, the number of IoT devices is increasing exponentially, and it is forecasted that the number would reach more than 100 billion devices by the year 2050. So that's why we need something that would be there to make all of this a secure process. Starting off with the IoT, right now, security is all that matters to a user. Cybersecurity and cybercrime, one needs to be implemented and other needs to be reduced. When every uh, when everything that is coming online with every device that a user is using, all of the user data is up there, and the communication that happens is at risk. The need for IoT devices is right now is that a trustless peer-to-peer messaging services, that is distribution of processes, a secure distributed data sharing is very important, and a robust scalable form of device coordination is essential in this world of IoT. This is where our beautiful blockchain comes into the play because it has a decentralized system and a trustless approach that makes blockchain the most the prioritized thing that would be implemented. Uh, what makes blockchain so secure is one of the identification methods that are being used, the private and the public key combo that helps in identification and authentication. And moreover, all of this process is autonomous. As you can see in this image by IBM, everything is up there over to the cloud and everything is connected with one another. So, what this paper is actually addressing is a need for something that is going to make the transaction between each device that is out there into the IoT to have a secure communication and the secure and obviously the whole concept of the security systems. So the IoT devices that we have connected are mostly not the ones that have that such of robust power that could um, run the whole blockchain computing system, because it's a uh, very heavy system and it cannot be run on those little devices that we are using into our day-to-day life. So in this paper we are giving the proof of concept in this, and what we are also proposing are the methods of integration for the various types of the end devices. And the software solution in this paper that is being presented is based on to the gateways that makes use of blockchain functionality to facilitate a decentralized IT platform and standardize the way to handle data transfer between the end devices and the whole IoT infrastructure, and to connect any type of end device to a blockchain IoT platform. In blockchain, it consists of the blocks which are cryptographically linked and they are timestamps. And the blocks are constantly verified by the nodes in a system to stand against the malicious attackers. So integrating the IoT end devices and the gateways to a blockchain-based IoT infrastructure, it can be accomplished in multiple ways. Here we go. These are the five ways by which the gateways can be implemented. The first is gateway as a full blockchain node. In this, end devices communicate with the gateway, where gateway operates as a full blockchain node. That is, it is routing the data and verifying the integrity. Coming to the second one, the gateway as a thin client. End devices communicate with the gateway, where gateway operates as a thin client by sorting only relevant data fragments using the protocols like the light client. Third point is that end devices act as regular sensors. The battery powered end devices can be so weak that no blockchain client is integrated with them. So IoT gateway will push the transmitted data to the blockchain infrastructure. The fourth point is that end devices as a server trusting client. A simple form of blockchain client is utilized that utilizes an interface like BCC API and that may be integrated to the battery power end devices. And the fifth and the last point of this is that end devices as a thin client in that if the end devices are not battery powered and they're always on, so they can operate as a thin client into this concept of integrating blockchain clients with the IoT devices. So this was the basic introduction of what is going to be done, and now Qayyum will continue with the proof of concept of this paper.
Hi, I am Mohammad Qayyum Ahsan, and I am explaining the proof of concept for the study. The proof of concept, they called it Blocky. In Blocky, what they have used that they used LPWAN for long range uh, data communication, and the instead of mesh topology they use the star topology. As my colleague explained it before that, the need of IoT and blockchain was consecutively increasing. So to cater these needs, a very well-defined structure and proof of concept was created. And blockchain was enabled on both sides of the gateway. So in this model, the LoRaWAN, that is basically the LPWAN, was used. And in LoRaWAN, if we try to indicate and to see the, further that what parts are included in it, we can find that this LoRa front end consists of Raspberry Pi 2 plus Dragano LoRa GPS head. And the gateway of that LoRa was Raspberry Pi 3 IMST IC 880, etc. LoRa software was used in it for the gateway, and then it, through this LoRa, the request was being forwarded to Ethereum client. LoRa is LoRa sends this information to Ethereum. Now, Ethereum is basically the open source public blockchain based distributed computing system. They use two of that system, one as a private Ethereum system and the second one as a public Ethereum system. Public Ethereum system was used to throw the request from LoRa gateway to the Ethereum blockchain. Now they use the smart contract between for the communication between these different systems. Once the query request is being forwarded from the public uh, get, that is basically the Ethereum blockchain, to the main core private Ethereum blockchain through smart contract, and then it activate the function over there and notify it back. In meanwhile, the Ethereum, the the public Ethereum is being monitored by the private Ethereum for any change. So if we glance this whole structure, there is small IoT devices that are linked with our LoRa gateway, and that LoRa gateway is then linked through a public uh, Ethereum system that pass our request to the private Ethereum blockchain system that mine it and further analyze it. So this complete study consists of this beautifully designed system and proof of concept that will help to solve this critical problem in future. Now we will come to conclusion. In studies, they mention that uh, in upcoming times, they are trying to work on their independent computing and the storage capability of these IoT devices. And with the passage of time, when the softwares will be developed for this, this will be a whole different landscape where this technology will be used smartly and efficiently. And this is the future of next generation. So we will conclude this presentation over here. Uh, Thank you very much.